When they first began studying the trajectory of the interstellar object 3I/Atlas, most experts didn't even consider how extraordinary its very existence was. This enormous object, weighing tens of millions of tons, was moving at a speed exceeding most known interstellar bodies. It had traversed not only billions of kilometers of empty space, but also entire regions that should have contained dense fields of cosmic dust, fragments of disintegrated asteroids, micrometeorites, icy fragments from the Oort cloud, all the chaos that typically turns any comet into a fragile, constantly suffering structure. But 3I/Atlas is still flying. And not just flying. It maintains its shape, mass, structure, and trajectory as if space itself were being created for it. And this poses a most unexpected question for scientists. How can an object of this size survive in space for so long without disintegrating? Most comets, even the densest ones, are short-lived. A single impact, even a microscopic one, is enough to create a crack in the surface that will eventually lead to destruction. Space is not a vacuum. It is a land of endless collisions, so frequent that any object traveling for millions of years should have long since turned to dust. Researchers from Harvard and Cambridge calculate that an object the size of Atlas should collide with cosmic particles every few hours. Some of these particles are so fast that an impact on a dense body is comparable to a bullet. Yet, 3I/Atlas shows no trace of impact craters, no fragments of a destroyed surface, no signs of degradation. On the contrary, the comet appears to be undergoing self-healing processes or is completely undamaged. There is a natural theory that the probability of collisions on large scales is negligible. But this theory only works for short time periods. For an object traveling for millions of years, such a probability becomes not just significant, it becomes a guarantee. If you throw a stone into a stormy sea, it will hit a wave. If you send an icy body into space for a time longer than Earth's history, it will inevitably collide with something that will destroy it. But Atlas is not destroyed. In fact, in places its surface appears too smooth, too even, as if micrometeorites leave no traces on it. And this leads to a hypothesis that hasn't even been considered before. What if 3I/Atlas not only survives in space, but avoids collisions? At first glance, this idea seems crazy. After all, a comet can't know that space debris is ahead. It can't adjust its trajectory to avoid it. But observations of Atlas have revealed a strange pattern. Each time the object passes through an area of increased particle density, its trajectory changes slightly. These changes are so smooth that they can't be attributed to chaotic gas emissions. They look as if the object is adjusting its motion. However, comets don't adjust their motion, only spacecraft do that. But Atlas continues to exhibit this behavior again and again, as if possessing some internal mechanism for orientation. Scientists studying interstellar bodies cite another example. When Oumuamua passed by, it also exhibited anomalous accelerations that could not be explained by ordinary ice ejecta. At the time, to avoid alarming the public, these accelerations were attributed to a hydrogen overload, a theory later refuted by those who coined it. Now 3I/Atlas exhibits similar behavior, but in a more complex form. While Oumuamua could evade collisions through internal processes, Atlas may systematically avoid collisions, as if predicting collisions in advance. But even if we assume that Atlas avoids large objects, what about the millions of microparticles flying throughout the galaxy? They are impossible to avoid. They collide with any body that traverses interstellar space. There are no gaps in their path. But Atlas shows no signs of impact. Why? NASA researchers have proposed a hypothesis. The object's surface may be so dense that microparticles simply leave no traces on it. But that raises another question. Why isn't the surface heating up? Any impact, even the slightest, generates heat, but Atlas's thermal radiation is too stable. And here begins the dilemma that has divided scientists into two camps. Those who believe Atlas is a natural object, and those who believe Atlas may be something more robust than a typical icy body. Some researchers suggest that the object is composed not of ice and dust, but of some form of super strong material that can withstand high-energy impacts. But then why does it look like a comet? Why does it have a tail that forms just like that of ordinary icy bodies? Logic dictates that a comet should disintegrate. But Atlas doesn't, turning it into a mystery that defies the laws of celestial body evolution. And yet, this creature. As observations of 3I/Atlas's trajectory continued, it became clear that the object's robustness wasn't the only issue. Robustness might explain the lack of evidence of collisions, but it doesn't explain why the comet flies as if it were maintaining a perfect line of motion. There are no straight paths in space. It's not empty space, but a complex system of interacting forces, gravity wells, microvortices, zones of increased particle density, weak plasma flows that are invisible to the eye but capable of altering the trajectory of any object passing through them. Yet Atlas follows its path so smoothly, as if the space around it were perfectly aligned. This isn't natural behavior. It resembles the motion of a body that has the ability to minimize the effects of its environment, adjusting its course before the deviation becomes significant. One of the most astonishing facts was observed by a research team from the University of Arizona. They studied archival images of the region of space through which Atlas passed approximately 200 years ago. This region contains a high-density cloud of microparticles known as the Liana cold layer. Ordinary comets crossing this layer inevitably suffer disruption. Some of their mass evaporates, their tails become ragged, and bursts appear in their spectra. But what did the data show? According to astrophysical models, 3I/Atlas passed through this layer without the slightest sign of interaction. Its mass remained unchanged. Its brightness remained unchanged. Even its velocity showed no fluctuations. And this became the first serious argument in favor of the hypothesis that the object may have a mechanism for avoiding dense regions of space. But how can an object avoid something it can't see? In a natural sense, it can't. Comets don't have sensors. They can't feel approaching particles or magnetic anomalies. They have no anti-collision mechanism. But if we assume that Atlas is not a comet, but an apparatus, even an ancient one, then everything looks different. Then it might possess a navigation system that works differently than Earth-based spacecraft. Perhaps the object uses the natural properties of physics to navigate obstacles, reacting to changes in space without the use of traditional sensors. Perhaps it has a layer that interacts with fields at the microscopic level, creating a protective barrier around itself that deflects small particles. This technology could explain everything from the lack of craters to the absence of cracks. Some physicists have proposed the idea of resonance navigation. If Atlas is capable of generating a micromagnetic field around itself, even a minimal one, it could interact with plasma, dust, and micrometeorite streams to prevent particles from reaching the surface. This is similar to the effect of Earth's magnetosphere, only on a smaller scale and in a much more complex form. Such processes could deflect most small particles even before they collide. But that raises another problem. To maintain such a field for millions of years, the object would need a source of energy that is not exhaustible. And here's where the hypothesis becomes too bold, because such a mechanism requires a technology that humanity won't master for centuries. However, even if we rule out the technological possibility, the question remains, why has Atlas never collided with a large object? After all, space is full of large bodies, wandering asteroids, frozen clumps of the Oort cloud, fragments of protoplanetary matter. The probability of a collision is so high that any object traveling for millions of years should have experienced at least one destructive event. But Atlas isn't just intact, it's stable. Its structure looks as if it passed through space without a single significant impact. This is impossible. And here a new hypothesis arises. Perhaps Atlas has already been hit, but the impact force wasn't enough to destroy it. This idea gained popularity after one research group discovered barely noticeable microdeformations in one region of the reflected light spectrum. These deformations could be traces of micrometeorite impacts. But if there were impacts, why didn't the object disintegrate? Because it could be significantly stronger than it appears. If Atlas is made of an unknown material, or if its surface is hardened by a natural process we don't understand, then the impacts could simply bounce off it without damaging it. Imagine a drop of mercury with tiny particles sliding across it. The object remains intact, and the impacts don't affect its shape in any way. There's also an alternative hypothesis supported by NASA experts. What if Atlas is an object whose shape ensures incredible stability? For example, the surfaces of some celestial bodies can be so perfectly smooth that microparticles simply slide across them, without transmitting impact energy. But comets always have dusty, loose, and uneven surfaces. Atlas doesn't. If we return to the idea that Atlas is capable of course correction, then another possibility arises. It's possible. Oh, the object has indeed collided with large bodies, but not in the way we're used to thinking. Perhaps it avoids collisions before an impact becomes inevitable. And this reaction is so fast and precise that it seems like luck. But luck, repeated for millions of years, becomes a statistical impossibility. It's either a miracle or a system. But the real fear lies elsewhere. If Atlas is capable of avoiding collisions, then it's also capable of analyzing space. This means the object can see space, not with its eyes, of course, but through interaction with physical fields. This is technology unavailable to humanity. But if it exists on Atlas, then it becomes clear why it's been flying for so long. Its trajectory isn't random, but purposeful.
But the most serious part of the debate began when researchers attempted to trace 3I/Atlas back tens of millions of years, modeling its motion in interstellar orbits. These models consistently showed the same thing. The object passed through regions of space where the probability of collisions was so high that any natural comet would have been destroyed within the first 100,000 years. But Atlas traversed this space as if it were flying along a corridor specifically cleared for its passage. However, such a corridor does not exist. There are no signs of destruction, no empty areas, no gravitational tunnels that could protect it. Does this mean the object chose its own path? If so, it possesses a navigation system we do not understand. The strangest conclusion comes from a research team from the European Space Observatory. They presented calculations according to which Atlas repeatedly crossed zones saturated with large icy bodies comparable in size to mountain peaks on Earth. Any contact with such bodies would have reduced the comet to a cloud of dust, but Atlas flew through these regions as if they didn't exist. And so a theory began to take shape, one that initially seemed fanciful but then received unexpected confirmation. Perhaps Atlas doesn't collide with objects because it has already collided with them, and those collisions failed to destroy it. This means that Atlas's resilience could be so high that only a planetary-scale impact could cause real damage. And this again raises the key question, is it a comet or an object that belongs to a category humanity hasn't even begun to dream of? Some physicists have proposed the hypothesis of an amorphous shell, a structure that absorbs the energy of impacts and distributes it across its entire surface, preventing localized damage. Such a shell could withstand multiple micro-collisions much like modern armor dissipates the energy of a bullet. But where in nature do such materials exist? And could they arise randomly during the chaotic formation of planetary systems? Unlikely. To create such a surface, technology is needed, and if the technology exists, then Atlas was built. But even more alarming was another hypothesis put forward by space mission specialists. What if Atlas doesn't simply adjust its motion but actually predicts collisions? In the modern world, we only have an approximation of this idea, primitive sensors that can warn of danger within seconds. But Atlas can operate on scales of hundreds of meters and millions of years. Perhaps the object uses interaction with space-time distortions to sense the approach of large bodies long before actual impact. This sense of space resembles not sensors but intuition stored in the device. If true, Atlas may be an ancient automated system that navigates through space, avoiding destruction not by chance but thanks to a built-in ability to analyze its surroundings. The most frightening part of the research was the analysis of shadow bursts, short intervals of time when Atlas slightly changed direction for no apparent reason. Previously, these bursts were thought to be mere sensor errors, but when the data was synchronized with cosmic density models, it turned out that each of these jerks coincided with the passage of nearby large masses. In other words, Atlas was evading potential collisions in advance. But how does it know there's an obstacle ahead? There's no answer. Technology, instinct, a built-in algorithm, or perhaps an ancient navigation system operating on a principle we don't yet understand. However, there's a theory that's even more exciting and even more frightening. Some scientists suggest that Atlas may be part of a system that uses gravitational drift, a kind of sliding along gravity's lines of force that allows it to automatically avoid collisions. Imagine a sheet of paper floating on water, the water itself circling obstacles around it, creating currents. If Atlas is capable of manipulating the local geometry of space, even at a tiny level, it could glide along a trajectory that at first glance appears straight but is in fact the result of micro-corrections. Such a system would explain everything: stability, survivability, trajectory, the absence of impact traces. But if we assume that Atlas not only withstands impacts but evades them, then it is moving toward a destination, and this destination, as many researchers believe, is not coincidentally connected to the solar system. Its motion does not follow a chaotic path like that of ordinary interstellar objects. It resembles a predetermined course, and if a course is predetermined, then the object's purpose is not simply to travel, but to reach a specific point. And in this case, it becomes clear why Atlas didn't crash into space debris, why it didn't disintegrate, why it didn't change course, trajectory. If an object is moving toward its target, it will avoid anything that gets in its way, it will adjust its path, it will maintain its shape, it will protect its structure because the goal is paramount. But another question arises, where is it going and why?